Welcome to our deep dive, everyone, into backup and recovery systems. We're going to unpack some serious knowledge about protecting your precious data.
It's going to be a great deep dive.
I think so too. And joining us on this journey is, well, a true expert in backup systems and architecture.
It's a pleasure to be here. I'm happy to share what I know.
Awesome. So let's set the stage here. We have a pretty comprehensive course laid out, covering everything from backup theory and information storage concepts.
We'll hit the backup client, storage node components. Oh, and of course, backup and recovery planning too. Can't forget that.
And to wrap things up, we'll have a hands-on course exercise and some good discussions to really, help solidify everyone's understanding.
Yeah, that's where it all comes together.
For sure. But for today's deep dive, we're laser-focused on Module 4, Backup Storage Node.
That's right. This module is all about equipping you with the knowledge to describe those critical storage node components.
We'll also be identifying those protocols used for writing backup data, and even weighing the pros and cons of, different backup storage media.
Lots to cover, but it's all important stuff.
Absolutely. So let's jump right into Module 4 and see what it's all about.
All right. The backup storage node is a crucial piece of the puzzle. It's essentially a workhorse in your backup environment, receiving data from various backup clients and efficiently writing it to tape or disk.
Okay, so it's like the central hub for all your backup data, making sure it's safely stored and readily available when you need it.
Precisely.
Got it. So now let's break down the first lesson within this module. Lesson 1 focuses on the core components that make up a storage node. It's kind of like looking under the hood of a powerful machine, right?
Right. And just like any computer system, we've got the CPU, which acts as the brain, internal memory for quick access, and those essential input-output devices for communication and data transfer.
Okay, so the CPU is crunching the numbers, making decisions. And the memory, or RAM, acts as a high-speed workspace for the CPU to use.
That's a great way to put it. The more RAM you have, the more efficiently the storage node can process information, which ultimately impacts your backup and restore speeds.
Oh, okay. So it's like having a spacious desk with everything you need within reach versus a cluttered one where you have to constantly search for things.
Exactly.
I like that analogy. And then we have those input-output devices, right? The connectors that allow the storage node to talk to the network and the storage devices themselves.
You're thinking of network interface cards for network communication and host bus adapters or HBAs for connecting to those disk arrays or tape libraries.
Gotcha. It's all starting to come together now. But what about the unsung heroes?
Yeah.
Like the internal bus and the operating system?
Those are critical too. The internal bus is like the highway system inside the storage node. It facilitates communication between all the components. If it's not robust enough, you can run into bottlenecks that slow down the entire backup operation.
So choosing a storage node with a well-designed internal bus architecture is key.
Absolutely. And then we have the operating system. It's like the conductor of this intricate orchestra. It manages all the hardware and software resources, ensuring everything runs smoothly and securely.
So we're not just talking about any operating system here. It needs to be one that's specifically designed for backup and recovery operations.
Right. You need reliability, security features tailored for data protection, and optimization for backup software and storage technologies.
Okay, makes sense. This is fascinating. It's like building a high-performance machine from the ground up, carefully selecting each component for optimal data protection. But hold on, we haven't even talked about memory selection yet.
You're right. Just like our brains need enough RAM to function efficiently, so does a storage node. Too little memory leads to swapping and paging, which can seriously impact performance.
So it's like trying to run a complex video game on a computer with limited RAM. Everything slows down, and you end up with a frustrating experience.
Exactly. Finding the right balance between memory capacity and cost is crucial for smooth backup operations.
Makes sense. Okay, so we've got the internal components covered. But what about the network? The bridge connecting our storage node to the rest of the world.
Ah, yes. The network is just as important as the internal components. Network speed and bandwidth directly affect backup and restore times. Imagine trying to back up a massive database over a slow internet connection. It would take forever.
Oh, it would be like trying to stream a high-definition movie on a dial-up connection. Pure torture.
Exactly. A fast and reliable network is essential for efficient data transfer between the storage node and the backup clients.
So a gigabit or even a 10 gigabit Ethernet connection is the way to go for optimal performance.
Especially if you're dealing with large data volumes or have strict backup windows to adhere to.
Okay, that makes perfect sense. But what happens when your data grows beyond the capacity of a single storage node? Do you just keep adding more and more nodes, leading to a management nightmare?
That's where scalability and consolidation come in. Think of storage nodes like building blocks. You can start small and easily add more storage nodes as your needs grow without sacrificing manageability.
So it's like having a modular system that can be expanded as needed without disrupting your existing backup operations.
Exactly. And many backup software solutions offer centralized management tools, allowing you to manage multiple storage nodes from a single interface, simplifying administration.
Talk about efficiency. This is great information. But before we move on, what about sizing the storage node correctly? I mean, you don't want to run out of space mid-backup, right?
Absolutely not. That's why understanding data growth rates is crucial for destination storage device sizing. You need to plan for the future and choose a storage node that can accommodate both your current data volume and projected growth.
So it's all about forecasting your storage needs and choosing a storage node that can handle the load, both now and in the future.
Precisely. And regularly reviewing your storage utilization and adjusting your capacity planning accordingly is essential to avoid any surprises.
Great advice. This has been a fantastic deep dive into the hardware side of storage nodes.
Yeah, we've covered a lot.
We have. We've talked about the CPU, memory, input-output devices, the internal bus, the operating system, and even network and scalability considerations.
We've definitely laid a solid foundation.
But we're just getting started. Up next, we'll explore the fascinating world of protocols, the languages that allow storage nodes to communicate effectively.
We'll delve into how these protocols enable seamless data transfer between different systems, even if they're running different operating systems or are located miles apart.
Sounds complicated.
We'll break it down. It will all make sense, I promise.
Great. Well, stay tuned, everyone, for part 2 of our deep dive, where we'll unravel the mysteries of NFS, CIFS, and other essential communication protocols.
Welcome back to our deep dive into backup and recovery systems. Last time, we took a deep dive into the hardware side of storage nodes.
Right, all those different components.
Exactly.
But now let's shift gears and explore how those components actually talk to each other and the wider world.
Good point. That's where protocols come in, the languages of the data world.
I like that, languages of the data world.
Yeah, they are essential for that seamless data transfer between different systems, even if they, speak different operating system languages or are miles apart.
So it's like having a universal translator for your data, making sure everyone understands each other no matter where they are.
You got it.
Love it. And in this part of our deep dive, we're specifically focusing on Lesson 2.
Protocols.
Right, protocols used for remote file sharing.
These protocols are the backbone of communication in backup and recovery operations, facilitating that movement of data between those backup clients and the storage node.
Okay, so let's dive into the first protocol on our list.
A network file system.
Ah, yes, NFS. I've heard of that.
It's been around for decades, a real staple in the world of data sharing. It allows users to access files on a remote computer as if they were stored locally. Creates a really seamless experience.
That's pretty cool. It's like having a magic portal that lets you reach right into another computer's file system and grab what you need.
You got it. And what's fascinating about NFS is its evolution over the years. Each version has brought new features and improvements, making it more robust and reliable.
I'm kind of curious about those improvements. Can you give us some examples?
Sure. Early versions of NFS relied on UDP, which was fast but not so reliable.
UDP?
Yeah, a connectionless protocol. But later versions adopted TCP, which is a connection-oriented protocol, much better for improved data integrity and error checking.
Okay, so it's like upgrading from a regular postal service to a trackable courier service for your data. You get confirmation that your data packets have arrived safely and in the correct order.
That's a great analogy.
Thanks.
Another key improvement has been the introduction of features like file locking, which prevents those conflicts when multiple users access the same file.
It's all about making sure the data is handled carefully and consistently, especially when it comes to backups, wouldn't you say?
Absolutely. Data integrity is key.
Okay, so we've covered NFS. What about CIFS?
The Common Internet File System.
Yeah.
CIFS is another widely used protocol, particularly in environments dominated by Windows systems. It's known for its compatibility with Windows file sharing mechanisms.
Makes sense.
And its focus on security and data integrity, of course.
So it's like the lingua franca of the Windows world, enabling seamless communication between different Windows systems, as well as other operating systems that support CIFS, right?
Precisely. And like NFS, CIFS has evolved over time, incorporating features like access control lists and encryption to enhance security and protect that sensitive data.
It's reassuring to know that these protocols have those built-in mechanisms to safeguard our backups.
Absolutely. Data security is paramount, especially when talking about backups. They are often the last line of defense against data loss.
Very true. So now that we've explored this communication side of things, let's talk about where we actually store all this precious backup data. In Lesson 3, we're going back to the roots of backup technology. Physical tape.
Tape.
The veteran of the backup world.
It might seem old school in the age of cloud and flash storage, but tape still plays a crucial role in many backup strategies.
I remember seeing those massive tape libraries in data centers, with robotic arms diligently fetching and storing tapes. It was like something out of a science fiction movie.
It is a fascinating technology, and while disk-based backups are definitely gaining popularity, tape still has its advantages, particularly for long-term archival and disaster recovery.
Okay, so tape isn't going extinct just yet.
hmm
But what makes it so well suited for those specific use cases?
Well, tape storage is sequential, meaning data is written and read in a linear fashion.
Okay.
It's like reading a book page by page. This makes it ideal for writing large volumes of data sequentially, which is typically how backups are performed.
So it's like having a massive archives of information all stored on tape. Perfect for long-term storage, but maybe not the best option if you need to quickly access a specific file.
Exactly. Tape is like a vault for your data. Secure, durable, and cost-effective for that long-term storage, but not designed for quick random access.
Makes sense. So what are the key advantages and limitations of physical tape backup?
Well, one of the biggest advantages is portability. Tapes are physically small, easy to transport, making them ideal for off-site storage and disaster recovery. Imagine having a backup copy of your critical data stored securely in a different location. It's like an insurance policy against data loss.
It's a great point. And you mentioned cost effectiveness. Isn't tape storage significantly cheaper than disk storage, especially for large data volumes?
Absolutely. Tape is incredibly cost-effective, especially when you consider the long-term storage of backups. You can store terabytes of data on tape for a fraction of the cost of disk storage.
Wow. So tape wins on portability and cost effectiveness. What about the downsides? What are we giving up?
The main downside is the slower access time compared to disk. Restoring data from tape can take a while, especially if you need to retrieve a specific file from a large backup set. It's like finding a needle in a haystack, you know? You know the data is there, but retrieving it can be a time-consuming process.
So it's a trade-off. You get affordability and portability, but you sacrifice speed and accessibility.
Exactly. Tape is a great option for long-term archival and disaster recovery, where speed isn't the primary concern. But it's not the best solution for operational restores or quick access to individual files.
This is fascinating. It's like each storage medium has its own strengths and weaknesses, and choosing the right one depends on your specific needs and priorities.
You're getting it. There's no one-size-fits-all solution in the world of backup and recovery. It's all about understanding the trade-offs and making informed decisions.
And speaking of informed decisions, those physical tape libraries you mentioned earlier, they sound like they require careful planning and management.
Oh, you're right. Managing a large tape library can be complex. It's like having a giant robotic librarian that needs to keep track of thousands of tapes, ensuring they're properly labeled, stored, and retrieved when needed.
So it's not just about buying a bunch of tapes and throwing them in a closet. You need a system, a process, and potentially some specialized software to manage it all.
Precisely. And that's where those robotic arms and sophisticated management software come in. They automate the process of handling tapes, ensuring efficiency and reliability.
This is incredible. It's like a well-oiled machine, with every tape carefully managed and accounted for. Amazing.
It's all about protecting your data and making sure it's accessible when you need it, whether it's for a routine restore or a disaster recovery scenario.
Okay, now let's fast forward a bit and explore a more modern approach to backup. Backup to disk or B2D?
BDD has gained a lot of traction in recent years. It leverages the speed and reliability of disk storage to streamline backup and recovery operations.
So instead of writing backups to tape, we're writing them to disk drives. What are the key advantages of this approach? Why would someone choose this?
Well, the most obvious advantage is speed. Disk storage is significantly faster than tape, both for writing and reading data.
Oh, okay.
This means backups can be completed more quickly and restores can be performed in a fraction of the time it would take with tape.
So it's like having your data readily available at your fingertips. No more waiting hours or even days for for a tape to be loaded and the data to be restored.
Exactly. B2D is all about minimizing downtime and maximizing productivity.
I can see why it's so popular. And I imagine disk storage is also more reliable than tape, which can be prone to wear and tear or accidental damage.
You're right. Disk drives are generally more reliable than tape drives. And with technologies like RAID, which mirrors data across multiple disks, you can further enhance data protection. You minimize the risk of data loss due to a single disk failure.
So it's like having a safety net for your safety net, double the protection for your precious data.
Exactly. B2D offers both speed and reliability, making it a compelling option for organizations that need quick access to their backups and can't afford lengthy downtime.
Makes sense. But doesn't storing everything on disk get expensive? I mean, disk storage can be pricey, especially when you're talking about terabytes or even petabytes of backup data.
That's a valid concern, and that's where the D2D2 strategy comes in.
D2D2T.
It's a hybrid approach that combines the best of both worlds. You get the speed of disk for operational restores and the cost-effectiveness of tape for long-term storage and disaster recovery.
Okay, I'm intrigued. Break down this D2DT strategy for me.
It's a tiered approach to backup. You first back up your data to disk for that quick recovery. This gives you fast access to your backups in case of accidental deletion, corruption, or other operational issues. Then, periodically, you copy those disk backups to tape for long-term storage and off-site disaster recovery.
So it's like having a short-term storage on disk for quick access and a long-term vault on tape for safekeeping and disaster preparedness.
Precisely. It's a smart strategy that balances speed, reliability, and cost-effectiveness. It gives you a comprehensive approach to data protection.
This is brilliant. It's like having a multi-layered defense strategy for your data. Disk for quick response, and tape for long-term resilience. Love it.
Exactly. And many backup software solutions support this D2D2T strategy, making it easy to implement and manage.
This is great information, but we've only scratched the surface of modern backup technologies. In our next segment, we'll explore the world of virtual tape libraries and deduplication systems technologies that are further revolutionizing how we protect and manage our data. Welcome back to our deep dive into backup and recovery systems. In the last two parts, we've covered a ton of ground, like the hardware that makes up storage nodes.
And those all-important communication protocols.
We even dug into those classic backup methods, physical tape and disk-based backups.
We did. It's fascinating how backup technology has evolved, wouldn't you say?
Absolutely. And in this final part, we're going even deeper into some cutting-edge solutions, specifically virtual tape libraries.
VTLs, yep.
And deduplication systems.
These technologies are really changing the game. They offer some incredible enhancements, efficiency, flexibility, and cost savings you wouldn't believe for backup and recovery operations.
It sounds almost too good to be true. But let's start with virtual tape libraries, those VTLs. What are they exactly?
Yeah.
And how do they compare to physical tape libraries?
Well, imagine a tape library. You know, all those tapes and robotic arms.
Yep, I can picture it.
Now, take away the physical tapes and the robotic arms. What you're left with is essentially a VTL. It's software-defined, emulating the behavior of a physical tape library, but creating virtual tapes that are stored on disk.
So it's like a virtual reality experience for our backup software. Like tricking it into thinking it's interacting with physical tapes, while in reality, everything is on disk.
That's a great way to put it. The backup software doesn't see any difference between physical and virtual tapes. That makes integrating VTLs into existing backup systems pretty straightforward.
So you get all the familiarity and ease of use of those tape-based backups, but with the speed and flexibility of disk storage. That's awesome.
Exactly. And VTLs have quite a few advantages over physical libraries. For one, they're faster and more reliable, and you completely eliminate that whole hassle of physical tape handling. No more boxes of tapes.
Sign me up.
May.
Okay, so let's break down these advantages. You mentioned speed. How much faster are we talking compared to physical tape?
Oh, significantly faster, especially when it comes to data restores. Because the data is stored on disk, we can access it way quicker than digging through a physical tape. That can make a huge difference in recovery times, minimizing downtime, preventing those operational disruptions no one wants.
I can see how that would be a huge benefit for businesses. Time is money, as they say.
Absolutely. And then there's reliability. Physical tape drives, there's robotic arms. They can be prone to mechanical failures. But with VTLs, you get rid of all those moving parts, so you reduce the risk of hardware issues.
So it's like removing a potential point of failure from our system.
Yeah.
Makes our backups that much more resilient.
Exactly. And since virtual tapes are just files on a disk, they're much less sensitive to things like dust, humidity, temperature changes, all those environmental factors that can mess with physical tapes.
Okay, this is making a lot of sense. But now the big question,
Huh?
cost. Are VTLs more expensive than those physical tape libraries? Because disk storage can get pricey, especially when we're talking about backing up a ton of data.
You're right, disk storage can be expensive, but the cost of VTLs has really come down a lot in recent years. And when you factor in reduced maintenance and increased efficiency, VTLs can actually be a really cost-effective solution in the long run.
So we're not just looking at the upfront costs, it's about the total cost of ownership over time.
Exactly. And many VTL solutions have flexible licensing options. That allows you to scale your virtual tape library up or down as your needs change.
Now that's flexibility. But before we move on to deduplication systems, are there any other considerations when it comes to using VTLs, gotchas we should know about?
One thing to keep in mind is that for optimal performance, VTLs typically require a SAN.
A SAN, what's
Yeah.
that?
A storage area network.
Okay, tell me more. What is it, and why is it so important for VTLs?
A SAN is a dedicated network, just for storage traffic. It lets servers and storage devices communicate directly with each other, bypassing the limitations of a traditional network. Think of it like a superhighway, just for data. For VTLs, this can provide the high bandwidth and low latency they need to efficiently transfer data between the VTL appliance and the backup server.
So it's like having an express lane for backup data, making sure it gets where it needs to go quickly, no traffic jams.
You got it. Without a SAN, a VTL's performance can really take a hit, especially if you're dealing with massive amounts of data or frequent backups.
Makes sense. So if someone is considering a VTL, they need to factor in the cost and infrastructure requirements of a SAN.
Absolutely. It's all about weighing those options and making informed decisions based on individual needs and budget.
Right. Informed decisions are key. Well, let's shift gears now and talk about our final topic, deduplication systems. I've heard a lot of buzz about this technology in the backup world, promising big storage savings and improvements in efficiency.
Deduplication is a game changer, truly. It's all about getting rid of that redundant data, shrinking the amount of storage you need for those backups.
Okay, I'm definitely interested. But how does it actually work? Walk me through it.
Imagine you have multiple backup sets with a bunch of the same files. Instead of storing multiple copies of each file, deduplication steps in. It identifies and stores only the unique segments of data, eliminating all those redundant copies.
So it's like a super smart filing system, automatically cleaning up those duplicates and freeing up that valuable storage space.
Exactly. And this can lead to some serious storage savings, especially for organizations with mountains of data or frequent backups. No more wasted space.
Impressive. But how does deduplication even figure out which parts of the data are unique? I mean, data can be complex.
Good question. There are different levels of deduplication, each with its own way of identifying and eliminating redundancy. The most common ones are file-level deduplication,
Okay.
fixed block-level deduplication, and then variable block-level deduplication.
Okay, break those down for me. What are the differences?
Sure. File-level deduplication is the simplest. It compares whole files to find duplicates. If two files are exactly the same, it keeps only one copy.
So like deleting duplicate files on your computer, just on a much larger scale.
Exactly. Then there's fixed block-level deduplication. This is more granular, dividing data into blocks of a fixed size and comparing those blocks to find duplicates. This way, it can even spot redundancy within files that aren't exactly identical.
So even if two files are just slightly different, this fixed block level deduplication can still find and eliminate those redundant chunks.
Yep, that's the idea. Now, variable block-level deduplication, that's the most advanced. It goes deep, analyzing data at the byte level. That means it can identify unique segments of data regardless of their size or where they are in a file. This method gives you the highest level of deduplication, making the most of your storage space.
Wow. It's like having a super-powered magnifying glass that can spot even the tiniest bit of redundancy.
I like that. It's true, though. Variable block-level deduplication is super sophisticated. But that also means it needs more processing power and can be more complex to set up.
So, like with many things in technology, choosing the right level of deduplication comes down to your specific needs and the resources you have available.
Exactly. Luckily, many deduplication solutions offer a combination of levels. That lets you tailor your approach to your specific data and backup requirements.
It's great that there's that level of customization. This has been a truly eye-opening journey, learning about how technology is constantly evolving to make backup and recovery more efficient and cost-effective. It's amazing.
It really is. And those advancements are essential as the amount of data we all generate continues to grow.
It's only going to get bigger from here.
Right.
So what's the next step for our listeners? How can they take all this knowledge and apply it to their own organizations?
The first thing is to take a good look at your current backup and recovery system. Figure out where the gaps are, what could be improved. Then look into those technologies and solutions that best fit those needs.
So it's all about building a strong, reliable data protection strategy that really aligns with your organization's specific goals.
Exactly. And don't be afraid to reach out to the experts. There are tons of resources and people who can help guide you through the maze of backup and recovery. No need to go it alone.
That's great advice.
Yeah.
Well, this has been a fantastic deep dive into the world of backup and recovery systems. We started with the nuts and bolts of storage nodes,
Discuss those essential communication protocols,
explored the pros and cons of different backup technologies.
and wrapped up with the amazing potential of virtual tape libraries and deduplication systems.
It's been an incredible journey, and hopefully our listeners feel empowered to protect their organization's valuable data, armed with all this new knowledge.
That's what we were hoping for.
So to everyone listening, go out there, tackle those backup challenges. And remember, data is the lifeblood of any organization, so protecting it should always be a top priority. Until next time, keep learning, keep exploring, and most importantly, keep your data safe.